The previous screencast reviewed how nuclear energy or nuclear reactors work in terms of the uranium and how it's bombarded with a neutron, and that causes chain reactions of bombardment and energy to be released. Anyway, so now here we're going to look at nuclear reactors, how they work, and what some of the safety issues are. So you have a containment structure, typically something that would also include maybe concrete, something that nuclear energy does not go through very easily, perhaps a lead lining. And you have within there the nuclear reactor shown here, but not labeled. In the nuclear reactor, you have a core which contains the uranium or thorium, whatever your nuclear source is. And in this core, the neutron is bombarded to cause or start that chain reaction. There are also control rods that are inserted into the core to stop the reaction when necessary. So let me go back a slide. When you have this chain reaction, if you lowered these control rods, you would prevent the energy, the neutrons, from continuing on to react with other atoms of your radioactive substance, and therefore you stop the chain reaction. So that's what control rods do. And then again, the production of electricity is similar to other sources that we have looked at. So cool water is pumped in, it surrounds the core, but the core heats the water because of all of this energy that's being released here by the chain reactions. And then this water then turns to steam, and the steam generator brings the steam over and turns the turbine, starting the electricity. Okay, so that's its own separate unit. But then the cooling water, after it's gone through the steam generator, the cooling water can circulate back out. And more cool water is brought in, and then it goes around in a cycle. Okay, so a couple of issues to talk about here. One issue is the possibility of a nuclear reactor meltdown or explosion, which would result in air, water, land, people being exposed to high amounts of high energy radioactive substances. So one example that many people have heard of is Chernobyl, which experienced a meltdown in 1987. Now, Chernobyl and other Russian nuclear reactor sites used a different type of water than what we do in the United States. They use a water called deuterium. It's an isotope. And the deuterium gets much hotter than regular water does. And so what happened was they were conducting a systems test. What would happen if there's a power outage and we have to continue to get this core kept under control in terms of temperature? But one of the problems, because their water did get superheated, that was one problem. A second problem was that there was human error during the test, and so the people running the test did not realize what was happening, that the control rods were not in place and the core was getting super hot. So eventually the super hot water caused an explosion, which caused the core here to be exploded as well, and came out of or exploded out of the containment structure. And many people in the plant at the time it happened died. Others subsequently died of cancer, including thyroid cancers. So that's one risk. But even in the United States, here in Pennsylvania, we had a nuclear reactor at 3 Mile Island, and it partially melted down. It didn't have a complete meltdown, but it did in fact still leak radiation. And what happened was there was a valve that was used to allow coolant to escape if need be, if there was too much pressure and heat being built up. But the operators at 3 Mile Island thought that's what was happening, that there was too much heat, and they thought the opposite was happening. Let me explain that differently. So they thought they needed to shut down the coolant, and when just the opposite is what they needed to do. They needed to bring in more water. And so it did result in a partial meltdown, and it was a result largely of human error, lack of training, also the design of the station where there was a little tiny warning light for what was actually going wrong, but it was sort of tucked away and not where the operators saw it. So that's one concern, that there would be a meltdown during the operation of a nuclear reactor. Let's look at some other issues. Okay, here we have the summary chart from the textbook. Advantages of nuclear energy: no air pollution is produced, is what the textbook says. Well, it's true. It doesn't have much in the way of CO2 emissions, and there is no sulfur released. However, there could be air pollution resulting from a malfunction. For example, when Chernobyl had the meltdown, the particles, the radioactive particles, found their way all the way to Scandinavia, where those countries started saying, wait a minute, where is this radiation coming from? And in fact, a very large amount of the radioactive particles ended up landing in Belarus, not at the actual nearby locations in Russia. So there still is a possibility of air pollution. There's also a possibility that some air pollutants are being released from those valves that are allowed, the passive valves that are allowed to open and release material and steam when pressurized. And no one has really studied to see they've begun a study, but they haven't thoroughly investigated what might be coming out of some of those passive valves. And another advantage of nuclear energy is that a country could limit their need for imported oil. That's why Japan turned to nuclear energy. Even though they lived in an earthquake-prone area, they didn't have any sources for oil of their own in their own country. And so they turned to nuclear. Disadvantages: possibilities of accidents or terrorism. Large amounts of very radioactive waste can exist for more than 10,000 years after its lifespan has ended. And we'll look at that on the next slide, as well as on-site storage and reactor life cycle. And again, there could be release of radioactive materials to the air. So let's look at radioactive waste. So that's waste where the nuclear rods that are in the core are depleted of having enough energy to produce electricity, but still contain highly radioactive material, daughter elements, if you will. And there has been no permanent or ideal solution to disposing of these radioactive wastes. So currently, up at Pilgrim, the waste, and this is typical of elsewhere, the waste is put into containers, these rods, in a pool of water, because one of water's unique properties is its ability to absorb heat and its ability to not transmit the radioactive energy, to absorb that energy. So physical heat and energy. And so they've been placed in these cooling pools that were designed to hold the radioactive waste for 5 years. However, the waste sat there for a total of 40 years. Excuse me. Excuse me. Okay, so after 40 years of collecting this waste, Pilgrim Nuclear Power Plant applied for another 20-year license to operate. As part of that licensure agreement, the Nuclear Regulatory Commission demanded that they have storage casks, so that for every nuclear waste, every rod of nuclear waste that was placed in the cooling pool, an older cooled rod would be placed in a permanent storage container called a dry cask. A dry cask is likely concrete lined with lead, very secured containers. The good news is these do survive a lot of earthquake activity. So when, excuse me, when the reactor in Japan, Fukushima, was hit with a tsunami, even though there was a lot of radioactivity that escaped from the plant in the reactor itself, the vast amount of their nuclear waste storage was in these dry casks, and none of those leaked radioactivity. So that was a positive. For the United States, well, excuse me, let me just go back a moment to Pilgrim. So they were given the license to continue to operate for another 20 years, but they continued to have degrading facility, and as a result of that, they were frequently on the list of unsafe reactors and things that needed repair before being allowed to continue. So many shutdowns, making it less efficient, and eventually they were designated to close. Right now they're trying to figure out how to sell that land, have a company come in to clean it up, and working on that process right now. Okay, let's see. One last thing I will mention about radioactive waste. For many years, the United States thought that they were going to be able to store radioactive waste at Yucca Mountain in Nevada. And so they continued to generate nuclear waste on the basis that sometime they would be able to move these casks to this underground in this mountain and be safe. However, for at least 10 years now, well, more like 20 years now, it was known that Yucca Mountain has a lot of seismic activity, a lot of earthquakes, and it would be an unsuitable location for nuclear waste as a repository. So that idea was finally shot down about 8 years ago, and now most nuclear waste continues to be stored at the facility where it was generated. Okay, so that is it for nuclear energy, and now we're going to look at the future of energy through renewable energy sources, energy conservation, and energy efficiency.